Thank you all for being here. It's really exciting to be here speaking in front of all of you. Earlier this morning, Malta did a great job of setting the stage and explaining to us why we are all here in the first place, including the part about why we're in Mountain View and not San Francisco. And John then gave us a great idea of how one can build powerful visual experiences for using AMP by talking to us about AMP stories. Well, now it's time to change gears a little and focus on you, the contributor, the web developer, the person who is going to get your hands dirty, pull out your laptops, and look at our GitHub repo and start contributing code. In this talk, we're going to go over the infrastructure that allows us to develop, build, test, and release the AMP runtime. So let's talk a little bit about who I am before that. My name is Raghu. Unlike most of our colleagues who are based in Mountain View and San Francisco, I and a couple others are based in the New York office. So I'm really happy to be here in California with all of you. I'm the technical lead for the infrastructure team for AMP, and I'm also an engineer at Google. In the past, I've worked on various projects at Google. So let's talk about what we're going to cover today. In brief, the agenda, I'm going to give you a rough overview of the tools and technologies that we use that constitute the infrastructure for AMP. Next, I'm going to go over the typical development workflow and the testing workflow of an AMP contributor. Now, these two sections can go into gory detail, but I'm going to just cover the basics and point you to the documentation. Then we're going to do a little exercise, a timeline. We call the first one the life of a pull request. It's essentially the flow that you will go through when you start writing code, and then how you build it, commit it, have it tested, merge it, etc. We call that the life of a pull request. And then, I don't know if Erwin's in the room, but there he is. Erwin, incidentally, was, I think, one of the first 3 people to ever be a part of the AMP team. So we're really lucky that Erwin's going to talk a little bit about the life of a release. And I had a section there for questions, but I believe we're doing questions at a later point. So let's move on. So most of you are probably looking at all these icons here. And if you've worked in open source on JavaScript platforms, you're probably familiar already with most of these icons, if not all of them. Now, as you know, AMP is open source, and our code is hosted on GitHub. And so while building the infrastructure for AMP, one of the guiding principles we've used has been to, as far as possible, use existing tools and technologies that are already compatible with open source development. So you might recognize some of these, and they're just a subset of what we use overall as part of AMP infrastructure. So let's jump into a little bit of detail at a glance. As you know, all our code is hosted on GitHub. The languages used in the code base for AMP and the infrastructure for AMP is a combination of JavaScript and some TypeScript. We do development using the Node.js environment. So you'll notice when you get your hands dirty and develop and start contributing to AMP, a lot of the stuff you run are going to be Node scripts written in JavaScript using the Node libraries. For package management, we got some of you who were here yesterday might remember the talks on the tips and tricks and sort of the life of a developer. And so you will be familiar with some of this stuff. But for package management, because we use a lot of open source third-party repositories and libraries, we use Yarn, and at some point we used to use NPM for package management. Those unfamiliar with Gulp, you're probably going to see a lot of commands in the talk right now that are Gulp commands. Gulp is nothing but a task management tool that is used to automate various build and development and testing tasks. So you'll hear the word Gulp, and it literally is the library we use. Following that, some of the tools we use for building. For starters, the version of AMP that we release to the world is compiled using the Clojure compiler. In addition to that, we'd like to make the development flow as fast as possible and as quick as possible. And so we have versions of our builds that are much faster and much more instant. They don't do all the optimizations and the code, the compression and all that stuff. And so we use things like Browserify and Babel and the TypeScript compiler for that stuff. Next comes the long tail of technologies and tools. And this falls under the bucket of testing. We do all our continuous integration testing on a service called Travis. I'm sure a lot of you might have heard of it. We do visual testing on Percy. We do cross-browser testing using devices and virtual emulators on a service called Sauce Labs. And I'm going to jump into some more detail about all these other things. And finally, you might be curious about if you commit a new feature or add a new component, you might be curious about how good your tests are. And so we do code coverage measurements using a service called CodeCov. And finally, given that we use a lot of third-party packages, at last count, I think the AMP HTML library had about 150 third-party packages that it depended on, either for building or for part of the tool set. Keeping them up to date is a difficult task, and doing it manually is almost impossible. And so we use a service called Renovate to do package management. So let's talk about the typical development workflow and how AMP's infrastructure comes into play while you're developing code. So let's jump into some basic facts. These are in arbitrary order. You already know that all our open source code, our tools, and our docs are stored on GitHub. When you do development on AMP, you might be curious to know how we release it. And so it's going to come up in the second half of our talk. But in brief, we have three main kinds of branches. There's the master branch, which means all the code that contributors to AMP commit get checked into the master branch. Once a week, we cut a new branch called a canary branch, and what this is that week's release. And so people who opt in to receiving the latest changes from the AMP runtime get to see the version of code that's built on the canary branch. And finally, when we believe that a canary branch is sort of well-baked and tested for a week, we put that out, and those branches have the AMP release tag. So when you look at our GitHub repository and look for the branches, you will find branches with these kinds of names. Another detail worth knowing is the runtime. There are a couple ways of building the AMP runtime, and I'm going to get into that. But in very brief, the runtime files that contain the core runtime for AMP are contained in one of two different file names, and they depend on whether you've done a minified build or an unminified build. And so those in brief are v0.js and amp.js. So if you look at a production page, I don't know, look at a New York Times article or a CNN article, and you look at the very top of the page, you will see a line that includes the v0.js script, and that in effect is the AMP runtime. When you develop AMP and you end up using a package, and it's very often the case that you might use a new package or change the version of a package, all that stuff is contained in our package.json file. So that's the central repository for all the third-party tools and technologies that we use for AMP. Managing packages, we used to use NPM in the past. We've been using Yarn for the past year or so. And so you will see that when you start developing AMP, the first thing you do before you can do any coding or building is to run the Yarn command. And finally, the kinds of builds that we do. I'm going to jump into some more detail, but briefly, we use the Clojure compiler for minified builds and the Babel transform for unminified builds. So what are these build types? Let's jump into some detail about those. The first kind of build is the minified build, and we do minified builds for code that we ship on the internet. So if you go and view the source of an AMP page, or if you just go to the CDN URL for the AMP runtime and you pull it out, it's essentially a plain text file, JavaScript, and very few spaces and stuff. That's called a minified build. So the command we use to generate the AMP runtime as a minified build is gulp dist. It's one of the several commands you will use during your development process. It uses Clojure compiler, and it's a little slow because it does a whole lot of things like type checking, optimizations, clearing out of dead code, etc. And what you get is the most compressed form of the AMP runtime. And this is the version that we ship, and so we use this version to release AMP. But it's cumbersome to do a really long build process each time you're making small changes and you want to sort of rapidly iterate through the building and testing on your local computer. Sometimes you're using a laptop that's not as powerful, and this is JavaScript, so you should be able to use that kind of a machine to build and test AMP. So the second kind of build we can do for AMP is an unminified build. Now, there are two commands that you might have heard of yesterday for those who were here yesterday. The first version is gulp build, which does a one-time build of the AMP runtime. It uses a transform, a couple of packages. One of them is Browserify that supports the infrastructure for transforming JavaScript code into a packaged runtime. And the second transform it uses is a plugin to Browserify, and that's called Babelify. It uses Babel. And what essentially this is doing is making sure that all this code can run on various browsers, because obviously you want your code to run on the multitude of browsers that exist in the world. So obviously this needs to be fast, it needs to run instantly, and so it does far fewer optimizations and that sort of stuff that we were doing using Clojure Compiler. And this is what we use for development and testing. So if you would like to, in fact, make changes and watch your code get built on the side, there's a version of build called watch, which essentially does a build and then sits around waiting for you to edit a file. And the moment you've touched a file and saved it, it rebuilds that file. And you can refresh your page from where you're pulling the AMP runtime, and you get to see the latest changes. So these are common things that you will see during the development workflow. Let's move on to testing. Now, I could spend a whole hour talking about the way the AMP runtime is tested, both when you check in some code and it's tested on our continuous integration infrastructure, and before that, when you do local testing. So instead of going into that entire list of things that we do to test, I'm just going to illustrate it with a screenshot. You're obviously not expected to read any of the stuff there, but if you go into the AMP, if you go to your command window and type the command gulp help, you will see the entire AMP toolset at a glance. So if you're curious about where to start, this is a good place to start if you want to get your hands dirty. One way I commonly use this gulp help command is if I want to do a certain thing, I sort of do a grep at the end of my gulp help command and see which commands can do various things like lint checks or optimized builds or dependency checks or JSON checks or checking the links, whether they're open, whether they work or not, if I'm adding links to external sites in my documentation. There's all kinds of tools. I'm going to very briefly show you a slide where some of these the critical path testing tools are on screen. Obviously, it's difficult to read all this stuff, but in short, to summarize this page, we do things like build the runtime, run different kinds of tests, unit tests and integration tests, do code coverage tests, run the runtime on various browsers, make sure that we haven't unduly bloated the runtime, do certain pre-submit checks for forbidden terms. For example, they may be security risks. So even though the JavaScript language allows you to use those patterns, we recommend that you don't in a runtime code to make it secure. We do things like lint checks to make sure the code is well formatted so that other people's code is easy for you to read and there's a uniform standard. And finally, visual diffing and validation. And you're going to hear some other talks about these aspects. So if you're curious about all this and you didn't pull out your phone right now to take a picture of it, you don't have to, because all our testing tools are described on our documentation page. The bit.ly link up there, bit.ly/amp-testing, should take you to this page. And you will see a detailed list of the hundreds of commands we use for testing AMP. Now let's get into the story time. Life of a pull request. Here's what happens when you pull out your laptop, check out the AMP code, and start working on it with the intent to send us a pull request for code review. In short, the timeline is as follows. The little blue text up top there tells you where this certain thing is going on. And obviously there's a flow. So let's start at the top. You start off having checked out a copy of the AMP code. You first fork the main AMP repository to your personal fork. The reason we make you do this is because that way anyone can make a fork and we can get pull requests from those who don't already have write privileges to our main runtime. And once you fork that and you make a copy of your fork on your machine, you then sync the latest changes on the master branch and you start writing code. And at some point you think you're done, and so you commit those local changes to your GitHub branch on your computer. Once that happens, you need to send those commits back to the cloud. And so the second step is what happens when you push the commits to your GitHub fork. We haven't yet created a pull request. So all we've done is written some code and updated the copy on your fork. But once you have the intention of making that change appear on the main AMP project AMP HTML repository, that's when you create a pull request. So the third step is from your GitHub fork, using the main master branch of the AMP repository as the baseline, you create a pull request. And so the incoming changes from your branch show up on GitHub as a pull request. Now here's where all the infrastructure kicks in. The moment you create that pull request and publish it, on the side, you might add people to review that code and make sure it's okay. But in the meantime, we want to make sure through a whole host of automated tests that the change you send us via a pull request does not break any of our existing tests and does not adversely affect the functioning of the runtime. And so we use a service called Travis. It's called Travis CI. It's a continuous integration platform. It provides us with a bunch of virtual machines on which we run all kinds of tests. And each pull request is separately tested on a new virtual machine. And so your your changes are tested in isolation from other changes that may be incoming at the same time. What happens there is the code is compiled, some tests are run, and at the end of it, a status is visible on your pull request saying if it passed all the tests. In addition to all the testing done on Travis, we have a few secondary checks that are run on the pull request directly from other services that we've integrated to our GitHub repository. And finally, once all these statuses go green and you receive an approval from someone who's already a committer or who's the owner of the file that you're trying to modify, you can then merge that pull request into the main AMP repository. And that, in short, is the life of a pull request. So this sounds a little cryptic and hard to understand if you're new. And since all you folks I expect to contribute to AMP at some point, let's look at a bunch of pictures to talk about what different things are going to look like as you get familiar with our infrastructure. So this is, as you can see up top here, this is a fork. So one of my colleagues created a pull request a couple days ago, and the pull request was created on one of the branches on their fork. And so they made some changes here. And the first thing you would do is click on the compare button, and it'll show you a difference between the base code on which you are creating those changes. Once you do that, you publish those changes, maybe add a description. Perhaps you would talk about a bug that you're trying to fix or a feature request that you're trying to solve or something. Maybe add a more descriptive piece of text there that says exactly what it is you're trying to do. And then the second thing you would do is probably request for a review from somebody you know whom you've already talked to. And at that point, you've populated all the necessary fields in the pull request. But what you notice happen within the next half hour or so is a bunch of statuses appear at the bottom. So you will notice, for example, in this pull request, the reviewers haven't reviewed the pull request yet, and so you can't really merge it, but all the checks have run, and those checks have passed. It's really reassuring to get a green check mark. Sometimes if you have flaky tests that you've added or existing tests that are flaky, it could be hard to get this to be a green check mark. But this pull request was successful in getting all the tests to pass. And so you might be curious about what these checks are. A simple way of seeing that is clicking the Show All Checks link to the side. Now, when you click that, as of today, it expands into a set of 4 different checks. The heavy lifting is done by the continuous integration check that's run on Travis CI. So at this point, what you're looking at is a page on the GitHub website. But if you click on the details link out here, you will be taken to the Travis website. And a thing worth mentioning here is that this is a required check. And so if your pull request doesn't really pass these Travis checks, then it's not going to be allowed to be submitted. And in future, we do plan on making all these required, but for now, they're sort of in advisory mode. So let's look at what a Travis check looks like in more detail. So clicking on the link for the Travis check takes you to a page that looks like this. As you can see at the top, this is the AMP project /AMP HTML repository. What this means is that for every pull request that comes to us on this GitHub repository, we have an equivalent place on Travis CI where tests are run. So for this particular pull request, you'll notice that we run tests on 2 virtual machines, and we do that to make things faster. We shard these tests and run them in parallel on 2 different VMs. And so the status of this build is shown as a combination of these 2. So you want to make both these green before you can actually be convinced that the build has passed. At some points, you may feel like you want to rerun a certain shard because you think something happened or there was a network problem briefly. You can always hit the rerun buttons here or restart the entire build. So those are some things you can do on Travis. If you're curious about what's actually happening on Travis, I'm going to try and click the play button on these videos. If I can. Oops, the second one didn't play. So I'll ignore that for now, but it's a 30-second GIF, and as you can see, there's a whole lot going on in the logs. And if you're curious, you can actually open the link to Travis and watch these tests as they're running, so you can see what's going on. So I'm going to replay the one video that did in fact load, and you will see things like the environment setup. It does a bunch of stuff, and then you'll see it does a build, and at some point you'll see a whole lot of green dots scrolling. Those 8,000 green dots are our unit tests, and the next few thousand green dots are our unit tests again, but run on a different browser using cross-browser testing capabilities of a service we call Sauce Labs. And ideally, you want all those dots to be green and none of them to be red. If any of those dots turn red, you will see some logging that tells you what test failed and why it failed, and hopefully it's directly related to the change you were trying to make. Guess I've got to hit this button. So another of our tests involves static analysis. This is a service we use as a third-party service. Some of you may be familiar with it if you worked on other GitHub repositories. It's a service called LGTM, and it does static analysis of code. So at this point, it's not executing any code. It's just looking at the changes. And as you can see there, there's green and red sections that are very faint here. I can barely see them from this angle, but if I look at them on the screen, so it's essentially a diff. So you'll see a minus and a plus sign, and that shows the code that's changed. And if you had done anything, for example, if you'd done a section like an if false, for example, that's a good test case because at that point it's unreachable code. This service is going to flag that. So it's just indicative of potential logic or security bugs in your code. And ideally, you want to see no alert changes here. The good thing is you can just see a green check mark on your GitHub pull request when these tests pass. So you only need to dive into this when you see a failure or a new alert. Moving on. We're checking in code to the AMP runtime. And as you probably remember, the AMP runtime and the AMP project on the whole is used across more than 6 billion web pages on the web today, across 56 million domains. What this means is that if a new version of the runtime comes out, it's going to be applied to all these pages. And so you want to be really sure that a new change that you're checking in does not adversely break it. For example, you may cause the text to reflow, or you may cause the box to spill out, or you may cause images to be misaligned. And these changes are really difficult to test with unit tests, because in a unit test, you're just looking at your component in isolation on its own web page. But what about testing a full-fledged web page to make sure that all the elements on it look the same between one change and the other? And the only thing that changes visually is the things that you intended to change. We use a service called Percy, which really the name comes from perceptual visual differentiation, or perceptual visual diffing. And what that means is the human eye is it's more likely to notice changes when you see them side by side, where you see the old version and the new version, and you can go quickly from one to the other and see what's changed. And that's the philosophy behind visual testing. And so over the past several months, we've added a whole host of visual tests that are automatically run on every pull request that comes into our repository. So when you see a link on your GitHub pull request, one of those links points to Percy. And when you click on that link, what you're going to see is this. Now, you'll notice here at the top that the changes came from a certain pull request. You'll see that we run those tests on web pages of 3 different widths. So there's a common mobile width, there's a slightly larger mobile CSS width, and then there's a desktop width. This pull request is out of the woods because it had no changes, which means that it did not make any visual changes to our existing tests. So it didn't break the layout of our well-known pages. And if you click on the information button there for your build, you will see information about the commit. So this was the base commit for your pull request, and this is the head commit, which is the commit that you are in fact testing. And it makes sure that there are no changes here. So if you do see changes, you will see something on the left-hand pane that shows you what the page used to look like and how you broke it. Another video. This is just to show you how many visual tests we have been running in the past. So if you really expand it, I'm not trying to let you look at all these pages with the intent of reading what's on them, but you will just see the kinds of pages. As you can see, these are test pages for various AMP components. Some of them you might recognize as screenshots of AMP stories that John and his team created. They created some of these test pages. So you'll notice that when you check in some code, you don't have to do a lot of the heavy lifting in terms of testing it on various page sizes. It's already done for you automatically with every pull request. So I'm going to move on now. So in short, that was a long story. And you've come to the end of that story right now, because we noticed that our pull request was approved. Thank you, Kathy. And once Kathy approved the pull request in this example, you see that the button to merge this pull request automatically becomes green. And so we are done with the testing and the building and the verification of these changes. And now when you click on that merge button, these changes are going to go into the master branch. So that in a nutshell is how your code gets into our master branch. But how does the code go from the master branch of AMP to the wide world and hit 6+ billion web pages? We're going to talk about that with our next section, which is the life of an AMP release. You will notice, though, that one last slide to show you, which is that when you check in your changes, all the tests are run once again on these changes once they're merged to master. And there's a special build here, which is an AMP release build. And this is how we're going to learn about how the runtime is released. So dealing with that, we have Erwin.
Thanks, Raghu. Hi, I'm going to talk about the life of a release for our AMP code base. It's also known internally as the life of an AMP release engineer, really, or the week of an AMP release engineer, since it officially becomes a full-time job for one of our open source contributors and turn into an AMP release engineer for a week. Here's my social media, Twitter's, GitHub, also on Slack. If you're not on Slack, join us on Slack, because that's where you can get up-to-date and in real-time updates for our release. I just posted that we are not going to do a production release this week because we are here in the contributor summit. Here is a quick top-level overview of our release schedule. Nothing too specific to remember here. The only thing you really need to remember is Tuesday. That is when we cut a brand new candidate release on from the AMP code base. So speaking of Tuesday, today is Tuesday. And at 11 a.m. Pacific is the exact time where we try and look for a candidate release on Travis. Specifically, we look for a green build. I have another slide here that I guess was not refreshed because I had to take a screenshot at 11 a.m. You would have seen one of the shots which would have turned green on our master branch. We don't specifically choose like, oh, 11 a.m., this is the one that we're going to build. If, for example, we had failing builds during Tuesday, we would pick the last green build. So that could have been on a Monday, for example. And that would be the new candidate release that we would be building and would deploy into our opt-in canary. So cut a new release at 11 a.m. Hopefully, that would have passed Travis, which Raghu had covered. Should have passed unit tests, integration tests, and the visual diffing test that we do on Percy. Once we have run gulp dist, we will package it up and put it into our release candidate channel. So you can get into this dev channel by going into bit.ly ampexp. You will find a dev channel button there that will opt you into the latest candidate release that we release on Tuesday. Then on Thursday, we take that opt-in dev channel and put it into a very small amount of traffic of AMP documents. This should be around like 1% of AMP documents. And we do that so we can monitor it for bugs and errors and performance regressions as well. So this is actually the code getting into userland space at that point, but a very small percentage of userland. So yeah, we monitor it for bugs for 1 week. These bugs are usually detected internally, or they can be submitted as a GitHub issue, and I hope everyone here knows that one of the biggest contributions that you can make to AMP really is filing bugs and errors. Not just feature requests, but bugs and errors really. We try and improve AMP and try to fix AMP during this time. And if there are any identified critical errors discovered during this phase, we will fix them without exception. We will never release AMP into our stable channel without fixing any of these critical errors. So what are critical errors? These are errors or issues that cause privacy or security issues. Any issue that causes user or data loss. Any issue that break existing AMP web pages in a significant way. So any like very noticeable UI bugs, for example, will definitely get fixed. Or any issues that would otherwise cause significant harm to AMP's reputation. So I'm pretty sure all of these are going to cause significant harm to AMP's reputation, so we need to fix them ASAP. Once we've ironed out and made sure that the candidate is good to go, on Tuesday the next week, that candidate release is going into the broader population of AMP pages. So that is going into our stable dev channel, or sorry, our stable channel. So it kind of takes at best 1 week, I guess, to get a certain piece of code into the wider AMP stable channel. Or at worst case, I guess, if you're in the tail end of the release cycle, you kind of have to wait for 2 weeks. So all of this work that we do can be tracked on GitHub. We have a special label called type release, which we kind of update whenever the code goes into these phases of the stages of the releases. For a detailed overview of our release process, you can go to bit.ly/amp-sched, or you can go join our channel on Slack, our release channel. Again, I just posted that we aren't doing any production release this week. And you can keep up to date as well for any delays or emergencies on our Slack channel. So, thank you.